Welcome back to Arxflix. Today, we're exploring an innovative paper titled E2LLM, Efficient and Extreme Length Extension of Large Language Models. This research tackles the challenge of extending the context windows of LLMs without spiraling training costs. Let's dive in. Training large language models, LLMs, with long context sizes is a costly affair. It demands extensive training hours and massive GPU resources. Traditional methods necessitate additional training procedures and the collection of long context data, further inflating the costs. This figure contrasts existing methods with E2LLM. Unlike older methods which need long context data and multiple fine-tunings, E2LLM leverages short context data to train just once and supports various context lengths at inference. Enter E2LLM, Efficient and Extreme Length Extension for Large Language Models. E2LL reduces computational costs dramatically and negates the need for collecting long context data. It uses short-length training data, performs a single training procedure, and supports different evaluation context windows at inference. E2LL is built on ROPE, rotary position embedding, enhancing it with two augmentation methods for scale and position index parameters. It ensures robustness across different context lengths during inference. This figure illustrates how varying the scale parameters modifies the interpolated context windows during training. Implementing augmentation on the scale parameter from different sample distributions helps cover diverse position densities. Extensive experiments on benchmark datasets highlight E2LLM's efficiency and effectiveness. It demonstrates promising results on long context tasks, matching or surpassing commercial models like GPT-3.5 Turbo. Here's a simplified rundown of the training procedure. First, sample scale and position offset parameters. Second, adjust rope embeddings using these parameters. Third, train the model using a short context window. Fourth, repeat steps 1 to 3 across different training iterations. Fifth, at inference, set scale parameters to extend context lengths dynamically. The training algorithm of E2LLM, represented in this figure, shows the steps involved in training the model efficiently with short-length data. E2LL performance on long bench and RZIV proof-pile datasets is impressive. It shows significant reductions in perplexity for longer context windows compared to baseline methods, confirming its efficiency. Testing on unseen scales reveals that E2LLM generalizes well. It maintains performance up to certain context lengths, proving its robustness. This figure demonstrates E2LLM as generalization abilities across unseen scales, showing satisfactory performance for contexts up to 120 kb heat tokens. Additionally, visualizations of attention heat maps indicate that E2LLM effectively indexes the correct positions when generating responses, another testament to its efficacy. These attention heat maps display E2LLM's ability to focus on correct index positions across varying context sizes. To sum up, E2LLM introduces a game-changing method to extend LLM's context windows drastically with minimal computational overhead. It forgoes the need for extensive long context datasets and integrates seamlessly into existing infrastructures. Looking forward, the researchers plan to apply E2LLM to larger models and context windows, explore more types of position encodings and LLMs, and release their models and codes for the community. That's all for today's summary on E2LLM. Make sure to like, subscribe, and hit the bell icon for more updates from Arxflix. See you next time on another deep dive into groundbreaking AI research. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.